Okay, então, let's share. Hi, everyone. Welcome aboard. Thank you for joining us today. I will share our mirror link here on the chat. Just check if everyone can access. So, welcome to our Systems and Complexity Concepts for Designer. It's a learning workshop. We will take in 90 minutes for this interactive session. This session will be recorded and will be available in our YouTube channel later. And this is an invite to stop talking about the systems and start designing for them. So the goal of this workshop is you gain practical experience and integrating systemic ideas into the ideation phase, ensuring your solutions are robust, interconnected, and future-proof. So let me introduce about our SI Design Hub core team before we start. I am Gisele, and I am based on São Paulo, Brazil. I am working as an innovation consultant, and I have applied system thinking and design thinking here in projects. And this is my colleague, Roma and Joss. Roma is based on Bengaluru, India. She is program manager at SI. Joss is SI founder. He is joining us from London today. And this is our agenda. So we will start with a share about systems and complexity theory, a card game explanation, and you have 30 minutes in a breakout rooms to test the cards around a challenge. It's our game time. Follow up the brief and a short wrap up. Okay. So guys, if you have any doubt, you can share in our chat, in Zoom chat. And just to start, we'd like to invite you for this icebreaker. So we'd love to know which design discipline do you come from. You can share the answer in this circle. Just pick this dot. Here we have a management, engineer, strategy, design. Feel free to add your discipline if you cannot find here in the circle. Let's take it 2 minutes for share this. While we are sharing, I just share with you guys. A Design Hub is a learning space, so feel free to share your LinkedIn profile here in this space to connect with members, with others, with peers. Okay. And here you can find a bit more about our research, the cards we use in the workshop. So you have a set of cards that bring concepts about holism, emergence, networks, relations, and you deep dive into each card and test it around the challenge in the breakout room. So let's see which disciplines people come from. Strategy, designing, public sector. Great. Here you can share your LinkedIn profile. Let's take more 1 minute. Consultant strategy. Most of them here. Great. It's a great diverse group. And again, guys, here you can find more about our research for the session. So I think you could start. I pass to you, Joss.
Excellent. Thank you, Giselle. So good to have you all joining. Just let me share my screen. And hopefully you found the mirror board. So we'll be working extensively on this mirror board today. I would encourage you to jump in here because it's a workshop and we're going to have breakout rooms and you will be sharing ideas there. So there's the mirror board. And once again, welcome. Good to see you here, Mark. Justin, your first time. Welcome to an SI event. Kevin, Lee, and so forth. Elizabeth, Joel, great. So we're talking about key concepts from complexity theory, and we've compiled those into concept cards for designers, for anyone really who's engaged in some kind of a design process at the early stages, to take those ideas and to ideate around the challenge to try and derive new insights and essentially a systems or complexity approach to that particular challenge. So those are the concept cards. You'll find them all down there. We have them laid out on the board. There's about 20 of them here. Myself and Roma will be walking you through them, and we'll be discussing a challenge and quick ideation sessions about how to apply those cards to that challenge before, in about 40 minutes, you people will be breaking out into these breakout rooms. We'll have about 5 of you in each room, and you'll get a chance to connect with your peers, get introduced, discuss, and do some peer learning together before we come back to a plenary. So that's the agenda today. We have a challenge which is around developing climate resilient cities. And let's say we've been hired by the mayor of a city, our city, to create a systemic design strategy for developing the climate resilience of one of the areas in this city. So we're at the early stages. We're going to apply some of these concepts to thinking about this challenge and developing a strategy to address it. So you can see there are 5 main sections here, and that's how the cards are broken out. There's 4 cards in each section. The 5 main topics, the first one's holism, and we've got a number of cards there. We're going to explore them in a minute. We'll walk you through them. The second one's around open systems. The third one's around a relational approach. Fourth is around networks and decentralization, and the fifth is around life cycle design, resilience and regeneration, and so forth. And those are the categories of cards. And we're going to start here at the top, and we're going to walk you through the cards in each section. So welcome you to join me up here on this first set of cards. I might even bring you all to where I am here so you don't get lost. And I'll let you switch this off. So let's jump in. I hope you're engaged and have your thinking hats. We're going to be applying this to one aspect of our challenge in a minute. So let's walk through this. Holism is the first concept, which is very important when we're dealing with complexity. If we become too analytical when we're dealing with complexity, we get too caught up in the details and we lose sight of the bigger picture. And because everything is connected to everything else in a complex system, we need to think more expansively. We need to step back and try and see the bigger picture. And we call that holism, which is really starting from the whole rather than starting from a detailed analysis of the parts. And within that, we've got 4 main concept cards. You can see here, there's holism, integration, looking at patterns and thinking about multiple dimensions of the system. And just step in here, systems approach is a holistic one. This means we seek to understand something primarily in the context of the whole that it forms part of. So a person in the context of their family, or a car in the context of the overall transport system, or a bank in the context of the broader financial system. That's holism. We're kind of always reasoning upwards to think about this thing in the context of the broader system. Before we go about changing parts, we seek to gain an understanding of the overall context in which the parts exist and how they're interrelated and affect each other and the whole system. So systems design, likewise, should start with a holistic consideration of the system we're interested in designing. And this is really important for thinking about interrelationships, but also for avoiding unintended consequences. When we go too narrow, too analytical, we can do something in one part of the system. We're not aware of the effects it might have across broader other parts of the system. So that's the concept. Here's Russell Ackoff. He was an architect and a famous systems thinker from the 20th century. He has some fascinating quotes. He says, in systems thinking, increases in understanding are believed to be obtained by expanding the system to be understood, not by reducing them to their elements. In understanding proceeds from the whole to its parts, not from the parts to the whole, as knowledge does. A part is never modified unless it makes the whole better. You don't change the part because it makes the part better without considering its impact on the whole. That's systemic thinking. If you optimize for the components of the system, you will invariably sub-optimize the system as a whole. So he's encouraging us to start from the top ready and think more broadly before we go about changing any of the parts, because we might actually optimize that part at the expense of the whole. Okay, so looking at these cards, I think I've kind of covered this first one, right? System design starts with a crude look at the whole. We do this by asking, what is the whole that the part I'm dealing with forms part of, reasoning upwards until we get to the broadest frame of reference, and then looking for the from that vantage point so we can see the many different factors involved. And understanding the different dimensions of the whole system. For example, a city involves multiple different dimensions, or even a challenge within a city like homelessness. It's not just one thing, not having a home, it's actually multiple dimensions to that. Okay, so here we're asking a question, how can a greater awareness of the whole help to inform our design approach? And that's holism. The second card is around integration. How can we better integrate the parts into the whole? So it's very core to, very foundational to systems thinking, this relationship between the parts, how the parts fit together into a broader pattern that interrelates into the whole system. So our current reductionist approach to design and engineering works by dividing complex problems up into their sub-problems, solving for them, and then recomposing the subunits into the whole through a hierarchical master plan. The result of this is the formation of specialized silos, boundaries, lack of horizontal information flows, and the creation of fundamentally disconnected systems because of these silos that we create, these verticals. Systems paradigm looks at the world in terms of relationships and integration. Systems are integrated wholes whose properties can't be reduced to those of smaller units. Instead of concentrating on basic building blocks or modules, the system approach emphasizes the principle of organization, how the components are organized or integrated into the overall pattern. To get systems that work for all, they need to be integrated and connected horizontally rather than decomposed and recomposed vertically into a hierarchical master plan. So hopefully those ideas are making sense to you. If you have any questions as we go along, you could drop them in the chat. Just going to cover two more, and then we'll give you a little bit of time to think about these around one of the challenges here. I'm going to pass it on to Roma to walk us through the second set of cards. So that was holism. Look at the parts in the context of the whole. Integration, which is about thinking about the pattern of organization, how the parts are integrated into the broader system.
Sure, Josh, thank you. I can read out the cards, and if there's any relevant example, just it would be great if you could add. Um, so for the pattern, systems are abstract patterns of connections between things. Thus, in designing systems, we are interested in how the components are integrated into whole patterns of organization. To be good systems designers, we have to be able to work with abstract patterns rather than focusing on the details of the parts. The use of abstraction involves removing successive layers of details from the representation in order to capture only the essential features that are generic to all entities of that kind and independent of their specific form. And pattern formation refers to the process whereby a coherent set of correlations between elements is formed and persists over time. As systems designers, we are interested primarily in the overall pattern in the system, the formation, integration, or disintegration of this pattern. So is
Yeah,
yeah.
so there's a quote about systems thinking that you got to kind of sometimes blur the details so that you can step back and see the overall kind of patterns, rather than getting too caught up in the details. But the question there was what does it mean to work with patterns rather than just parts? We'll leave that one with you. Let's take a go. We've got multi-dimensionality, look at different dimensions.
So multidimensional, how can we work with the multidimensional nature of complex systems? Reductionism reduces downwards, optimizing systems by reducing them to a single dimension or a single function. A holistic approach works by trying to increase the degrees of dimensions of functionality of a system. So most things we design today, we design to optimize a single function and output, thinking that through reduction, we can improve output volume and efficiency. However, this logic only holds when taking a partial view of the system. So when we take a holistic view, we see that by elements functioning along multiple processes and dimensions, the whole system's functionality is improved. So systems design is about optimizing for the whole, not just the parts, and this often means having to consider and work with multiple functions and processes at the same time.
Maybe an example is the building, you could just optimize it for whatever it is, as an office or a house, but it can also be many other things. The system for capturing rainwater or for producing food or electricity and so forth. So thinking about everything in a multi-dimensional way instead of a monofunctional way. So those are the initial set of cards around holism or a holistic approach. Let's try these out with you people. So we're here. Please join me here. I'm going to pose a little question, and we'll have a few minutes for you to have a think through this idea of holism in the context of the challenge that we have. So we're going to take one of these dimensions of developing a climate resilient city. Can we come up with an idea that illustrates the application of this principle of holism to the challenge of car dependency within the city? So you can build upon, that general principle, any of these ideas here, have a think about them and think about, we've got this challenge of car dependency within our city, and we know that's not going to help in terms of, you know, climate change and the emissions. So how can we apply one of those ideas to this challenge? Um, and there's a little challenge for you. Maybe I'll give you 4 minutes to think this through and try to take whichever concept resonates with you and give us an example of what it'd be like to apply it here. If you have any questions, drop them in the chat. Feel free to take a bit of time to read over the ideas, have a think about it. This is not obvious. It takes some time to learn ideas, to reflect about how they could be applied. So you might not have the answer straight away. Maybe take a minute or even two to have a think through this, read over the cards, and then try to apply.
I think we could have the music. It can help us think.
Roma, do you want to pick up on some of these?
Sure. Joss. So some of them are really interesting. I'll start by reading the pink one. So it says 15-minute village neighborhoods as a pattern, which can be modularized and integrated with basic needs in all and specialism in each, encouraging local traffic in non-car transport. And then mobility as a service. Perhaps consider car dependency relative to sustainable cities. And then integrate better carpool services to existing market, changing public mindset on the importance of private cars as a way to change patterns. And then design a transportation system that connects public offers, carpooling, safe walking routes in order to make it easy, safe and accessible for people to go from A to B to C.
That one's interesting. Because it's kind of about integration, isn't it? Because to become car independent, it's not just about cars, is it? It's also like you need to be able to walk, you need to be able to cycle, things need to be accessible. Many things need to come together to be able to move away from a car. Yeah, just to go.
Yeah, so then we have explore the potential for new bike lanes, paths in best use spaces along with corporate foundational support, employee subsidies to stay out of cars, capital spent on infrastructure. And then we have ideas over here, the capacity of public transformation for each part of the city. Can we divide the city into smaller parts or into specific categories based on their nature, entertaining, cultural, residential, to see the dependency of cars so we can replace cars with other public transportation? And is the city multicultural? How much? Maybe, maybe we should consider culture differences for further solutions and what local residents' approach or relation is towards using their own car or public transportation.
Okay, let's take over. I think we're a little short on time, but thanks a lot for adding that. Hopefully it helped you think through this. And that's the whole purpose. That's where the magic comes when we get these powerful ideas without them, and then you think through what they mean in this context so that you can really see how to unlock them. You'll have more opportunities as you go to your breakout rooms. Let's take over for the moment just to get a view of all these cards. So the next one, that was all about holism and integrated systems, and this is about open systems. So complex systems are fundamentally open, like the internet or cities or social networks. Anyone can join or leave, and their boundary is permeable and diffuse. This characteristic of complex systems changes fundamentally how we should go about designing for them, as without boundary conditions, we do not have the same kind of control, and we may have when they can be bounded and are closed. Without the capacity to directly impose order on the system, we have to work with processes of self-organization and emergence. Most of all, this loss of control. Most of all, this loss of control and being able to impose order on the system requires the designer. We learn to work with context as a way to shape the outcomes. So unbounded, working with context and trying to understand processes of self-organization so that we can get emergence. So the key ideas here. Many complex systems, as we noted there, are so complex or large that we can't really understand all the parts or predict or control them, like the internet or smart city or something like this. So we have to change the paradigm to where we're designing for open systems instead of well-bounded closed systems has a number of major implications. For example, having to give up the idea of predictability and control and so forth, and even designing for perfection. These kinds of systems we have to try and work with the context to influence the parts instead of trying to directly control them. So that's one principle. How can we create more fluid boundaries and open systems? Is the first one. The second one's about context. How can we promote desirable outcomes by influencing the context? So complex systems do not have linear causality. Thus, we can't say if I do this, we'll get that. It's kind of complexity theory tells us that there may be aspects of that, but complex systems are generally quite nonlinear. And this really requires that we change our whole approach and shift up from directly influencing things to thinking about the context within which they exist and influencing that context. To work with complex systems is to shift our approach up from working with parts to dealing with context. Designing for context is not something we used to, but something we need to learn about. When the system is open, we do not have the privilege control. Instead, we only get to influence it. So it's a bit like having a child in a school and they're not doing very well. We can blame the child and try and make them do better, or we can think about the overall context they're in and whether everything is in the right place and try and influence that context. Are they getting the right food and sleep and social relationships and support that they need is a way of thinking about the broader broader context and influencing that as a way to shape outcomes. So number 7 is self-organization. How can we enable the conditions for self-organization or the context for it? Self-organization is the spontaneous creation of overall pattern of organization out of the local interactions between initially independent parts. We can think about people crossing the street and how they self-organize as they bump into other people and create streams of pedestrian streams to go past each other. That's a form of self-organization, and no one's in control, and it's emerging from the bottom up, the interaction between the parts. So without formal design and centralized coordination, components interact in a networked fashion. The type of organization and pattern that results from this are defined by the type of interactions between the parts and incentives they experience. So it's like the flocking of the birds, murmurations of starlings, where we see those beautiful patterns. That's all about the local interactions and rules that each bird follows in terms of following its neighbor or, going in a different direction and so forth. And out of that emerges a global pattern of organization. Are we able to influence that, change the context so as to get self-organization? Number 8 is emergence. That bigger pattern that emerges, we call emergence. So how can we create spaces that support emergence? Yeah, maybe you want to read this one, Ruba.
Sure. So emergence, how can we create spaces that support emergence? Complex systems are more like living systems. They typically have lots of adaptive actors that are following their own agenda, like people in an organization, cars in a transport system, or producers in a supply chain. We do not try to impose order, we instead try to create the conditions that are right for it to emerge out of the actions of the agents in the system themselves. The fact that the future emerges is a key source of the fundamental uncertainty within complex systems. If we take something like the internet, we do not know what future technologies will be built on the network, nor how those technologies will combine to form new possibilities. Needless to say, as the future is uncertain, we need to design systems in a way that is open to the emergence of different outcomes.
Great. So that was all about open systems and designing, working with context, self-organization to try and realize emergence. And our question here for the next few minutes for you to think through, come up with an idea that illustrates the application of this to creating awareness around the challenge of climate change in the city. So this is one dimension to our overall challenge of helping the city adapt to climate change. One aspect is developing awareness, and how could we use some of these ideas, one or more of these ideas, and apply it in this context to come up with innovative and new ideas. So let's take 3 minutes for that as you think through it. Rama, do you want to take a look at some of these?
So we have, starting with pink sticky again, encourage street gardens, including tree planting and innovative places to place a garden. Example, curbs and planters pull it, run off, and irrigate the trees and plants. Passive benefit drops the temperature of the street in the heat. And then street art of showing climate. Yeah, street art of showing climate challenge for people to immerse in the context, but also have chance to add on. And then whole contests of less waste with the unit of a neighborhood. How citizens assemblies talks free workshops to encourage discussions and co-learning, and then create crowdsourcing platforms to invite public brainstorm ideas and collaborate on eco initiatives, holding competitions for inviting designers, researchers to come up with the ideas, exhibiting them in public, then making use of public space for free exhibitions in museums and parks, teaching climate awareness to children.
Okay. I think that's good. Let's move on, and so we've covered holism and open systems, and that was all about context, emergence, and self-organization, how to work with that. We've got 3 more sets here before we break out. So relational approaches. This is thinking about networks and how we take an approach that looks less at focusing on the parts and improving them and more about the relationship of the parts. For example, the synergies between the parts or the protocols through which what enables them to connect. So this first one here, protocols. Systems are what emerges out of the network of connections between parts. To design systems, we need to design the connections between them. Connections are governed by rules of interaction. 2 things can only interact successfully are that if there are some rules to govern their interaction. These rules we can call protocols. Well, one way to approach the design of a system is to ask, what are the rules of connectivity and how do those rules lead to outcomes? So by defining the protocols, we can define better what interactions happen and what outcomes emerge. In defining the language of communications, we can define how the interactions take place and what gets done and said and so forth, and shape those relationships. The World Wide Web is an example. Those protocols allowed us to connect all our computers and build a lot of things together out of that, and that's just a set of protocols that allows us to connect. So that was number 9, protocols. Synergies is number 10. How can we define a synergy? Could be defined as the interaction or cooperation of 2 or more elements to produce a combined effect greater or less than the sum of their separate parts. So it's where the whole is different from the individual parts. We add 1 and 1 and we get 3 because of the value that's added between the particular relationship of those 2 parts. A synergistic design approach is one that's focused on the interaction between the parts within the organization to identify and develop synergies. With systems design, we're trying to minimize the negative synergies. The negative synergies are when things interact in a destructive fashion, like noise pollution. You're trying to sleep right beside, a big highway or a big party or something. There's interference. It's a negative synergy. And we're trying to turn those into positive synergies. When we design the connections and synergies, we aim to put things together that work together and reduce the negative waste. So that's actually a really interesting framing and way of looking at systems and how to influence, change, and design them. This thing of looking at the nature of the relationships. Are they interact in destructive ways? And how can we change that to more constructive ways? Okay, moving on. So non-linearity. How can we work with feedback loops and nonlinear process of change? Designing complex systems involves a high-level awareness of nonlinearity, that the outcomes to many systems is not a product of some linear cause and effect relation, but instead a function of many things interacting in a network fashion. Processes do not just take place from start to finish independently along one process. Instead, many different processes and functions are taking place within a parallel architecture. They interact across and between processes and domains in a network fashion. So it's also thinking about, feedback loops, how things can amplify or dampen each other down to create balancing feedback loops or amplifying feedback loops. And that is nonlinearity. And the final one here is around circularity. How can we turn straight lines into circular systems? Systems design requires designing for feedback loops, working or looking at how processes are connected in a circular design pattern. Much of our current approach to design focuses on optimizing the parts within silos without due consideration to the flows within the whole system. The results are linear processes of inputting resources from the environment and outputting waste again. And designing for circularity means how can we actually take those lines and turn them into circles on many different levels. So circular design is a key part of systems design. Another principle here. We can jump into our question here. We're going to apply this one to creating a resilient water system for the city. And we have a few different ideas. Let's just recap them there. Designing protocols, the rules through which things communicate and can work together. Synergies, the nature of a relationship. Is it positive synergies? Trying to change negative synergies to positive synergies. Non-linearity, and these feedback loops, changing straight lines into circles. Let's take 3 minutes to apply those ideas to this idea of creating a resilient water system for the city. Okay, we're going to stay moving on for the sake of time. Maybe, Romy, you'd like to read out some of these cards. So this is all about decentralized networks and taking a networked view, a modular, user-generated, decentralized perspective to design. And maybe I'll let you read out some of the cards, Roma.
Sure, Joss, I can start with the decentralization. What would a decentralized approach to the systems design look like? So, the decentralized networks are without centralized nodes. Responsibility, control, and resources lie on the local level and are dispersed amongst a large percentage of the nodes. Decentralized networks typically require greater user engagement as they cannot depend on centralized batch processing. The nodes in the network are often more self sufficient and less specialized, and thus it is easier to interchange and replace any nodes with any other, making them less susceptible to attack and more robust to failure. And then decentralization can reduce inequalities, increase inclusivity, and harness the capacities of more people among more dimensions. They also have fewer dependencies and are typically more sustainable in the long run. So, is there an example just for decentralized?
Yeah, I'm just thinking about in Mexico City, we have that case study of Isla Urbana, Roma, where they instead of depending upon the traditional linear centralized water system, they developed these decentralized rain harvesting water containers where everyone could put them on the roof, and then they have their own plumbing systems of ways of capturing water and providing water for themselves in a decentralized way instead of, and it's also modular design also. So maybe I'll let you stay going here.
Andre, thanks for sharing that. So, modular, how can we take a more modular approach to the systems design? When designing a system, one of our key architectural consideration will be to decide whether we are building a homogeneous system or a modular system. Modular design is a design pattern that is built around the idea of autonomous modules that can be independently created, easily configured, and reconfigured into different systems. The advantages of modular design include they can enable distributed collaboration and problem solving. Modules can be endlessly reused, like Lego bricks, can be combined and recombine them and making them, sorry, like Lego bricks, we can combine and recombine them, making it more likely to be a circular, sustainable solution. Modular systems are much more versatile, adaptive, and can be customized more easily. Modular design can be a very important contagion mechanism and should also be much easier to manage over the maintain the life cycle of the system as components can be easily swapped in and out. So there's a good example of Lego there. Moving on to the user generated. How do we design to engage and harness the productive capacity of the users? At all stages in the formation of our design, we should be thinking about user engagement and how to enable end users to be productive in creating their own solutions. Design should be about empowering people, not constraining. With the advent of digital technologies, we have the possibility to really empower and engage people in the creation of the world they want to live in rather than impose our solutions on them. This requires first thinking how do we push productive capacity out works to the end user, and then putting the means of production in their hands, and then build a network to enable the coordination of production and exchange between peers. This may be a digital media platform to produce and exchange media, transport with car sharing, or manufacturing with distributed fabrication. Um, I'll read the last one, which is service systems. How do we design for services and service networks? As connectivity proliferates, we move more and more away from standalone systems and into the world of service networks. The job of the system designer is to understand and work with these dynamic networks, their structures, and how that results in the overall functionality. In this context, systems design is focused on the design of networks that integrate diverse and autonomous, often user-generated modules to deliver an integrated service. This requires the development of platforms with protocols that can integrate diverse components within a shared infrastructure of connectivity and data while enabling the components to retain their autonomy through loose coupling. A good example for this is like Uber, I think.
Yeah, or even the internet itself, the way it's been created by so many different companies and so many different routers and data centers around the world, all coming together in a network, which is kind of a user-generated system. But maybe we'll stay going because we're a bit short on time. I just want to touch upon some of the final ones and then let you break out into the breakout rooms and you can read over some of these yourselves. So we've talked about the four main sections so far: holism, open systems. So holism was all about, integration, the relationship between the parts and the whole. Open systems was all about working with context, self-organization, and emergence. A relation approach was thinking about the nature of the connections between things, the synergies, the feedback loops. Decentralization is all about networks and how can we create more modular, decentralized, flexible, user-generated systems, maybe more agile also. And the final section here, I'm just going to touch upon it because we're running a little bit over time. We want to give you good time in your breakout rooms. Is think about the life cycle and questions around how do we actually create or design for regenerative systems. We know diversity is part of that. We know resilience and adaptive capacity are really important parts of this. And it's going to be very important in the context of the challenge we have today. So within our traditional design paradigm, it's very much a linear life cycle where actually they kind of degrade over time. And they generally resist change and designed to operate within particular kind of constrained parameters and environments. How could we design systems that they are regenerative over their life cycle? And they are they're resilient and adaptive. How do they have adaptive capacity built into them so they can adapt to changes in their context? And this often involves bringing in the aspect of diversity. So yeah, the first one's shifting from kind of linear degrading over their life cycle to one that's actually able to regenerate themselves. The second one's about how do we design to promote and strengthen diversity in the system over time, so it doesn't maybe converge towards homogeneous elements, but actually regenerates diversity over time. The third one is around adaptive capacity. How do we build that? How do we integrate a adaptive capacity into the system? And finally, resilience. How can we design to promote resilient and anti-fragile systems? Anti-fragility is when the system actually gets stronger through having influences because it's able to bounce back from them. Okay, I'm going to leave you people to explore those cards a bit more in your breakout rooms. We wanted to have 30 minutes so that you can connect and discuss all of these. Rama, do you want to tell us what's going to happen?
Sure. Thanks, Josh. So I hope we are now familiar with the principal cards, and I think that should make the game easier. So we will play this game in a group of 5, and I think one room will have 6 members. So we'll be in the breakout room for 25 minutes, considering the time. And each room will have, like I said, 5 to 6 members. And we will work on this challenge, which is we have been hired by the mayor of our city to develop a systemic design strategy aimed at strengthening the climate resilience of one of the city's areas. And the particular interest here is in understanding how a systemic design approach can be applied to address this complex challenge. So now that we are experts in the room now, the way we will play this game is there are 5 different sections around the circle. So first person, one of the person in the room volunteers to start the game, to lead the game. You pick one of these cards and then drop it inside the circle. And then the team ideates around it using sticky notes or talking to each other. This is a good place for you to start discussing and build connection with the peer group. And each card gets played for 5 minutes, and then the next person leads the next section, which is relational approach, and pick one of these cards, bring it to the center, and the group ideates around that for 5 minutes, moving on to next person, and then again for 5 minutes. And that way, everybody in the room gets a chance to lead one section and play one card and discuss around how to apply that card for this challenge. So that's about the challenge. So once we get into the breakout room, it's good to kind of quickly introduce each other, get to know each other briefly, and then self-organize. The first person volunteers to start the game and selects the section, selects a card, and then the team ideates around it, how to apply it for 5 minutes, and then pass on to the next person, and that person pass on to the next person. So that way
Right.
we'll be in the room for about 5 minutes. I think we'll have 2 breakout rooms, and we will.
We could probably have 3, couldn't we? Then have like 3 or 4 people per room. Yeah.
Okay.
Yeah.
Sounds so.
Okay, I'm going to create breakout rooms. I think we're all good, aren't we? Yeah. Thanks for that explanation. You also find so yeah, if you're in breakout room 1, then go to this first board here. Maybe we'll put stickies on them. This would be room. Oh, you've got numbers. Okay, there's 1 there, 2, 3, and yeah, just you got your stickies at the top there in case you get lost. We'll also join to help you people. So let's get started. Hopefully, yeah, you should have an option to join your room. Anybody need help?